This is the video for questions 54 through 57. Base your answers to questions 54 through 57 on the passages below. Meteorite composition. Meteors that strike Earth's surface are called meteorites. Analysis of meteorite composition has provided scientists with information regarding the formation of Earth and our solar system, and possibly the development and evolution of life on Earth. Two types of meteorites are iron meteorites and chondrites. Iron meteorites consist mostly of iron and nickel and are inferred to be from core materials of early planetary bodies in our solar system. More than 60% of meteorites studied have been identified as chondrites. Chondrites are made of millimeter-sized spheres of olivine and pyroxene crystals embedded in mass of a mineral and metal grains. The chondrites are thought to represent fragments of the earliest solid materials in our solar system. One type of chondrite, the carbonaceous chondrite, contains water, organic compounds, and minerals that represent the chemical composition necessary for life to form. Question number 54. Identify the meteorite that is inferred to have the composition similar to the composition of Earth's core. Now, this section almost seems like it belongs on a English Regents. It comes down to being able to read the passage and find out a lot of the answers. Now, the first question is asking, what is Earth's core made of? There's two ways to actually get this answer. So it says here, it says iron meteorites consist mostly of iron and nickel and are inferred to be from core materials of early planetary bodies in our solar system. Okay, so that kind of tells you that a lot of it is, going to make up the planets, right? Because it comes from the early planets, it comes from materials of early planetary bodies in our solar system. But if you're unsure of this and you really can't tell exactly what we're talking about, if you go to the Earth Science Reference Table and you go to this page 10, Inferred Properties of Earth's Interior, if you look here, Earth's center, the inner core, here, and is made of iron and nickel. So the question asks, identify the type of meteorite that is inferred to have the composition similar. So we said there are two types of meteorites, so the one that you would pick is iron meteorites. And if we go, we look at number 54, allow one credit for iron meteorites or iron. Back to the exam. 53. Identify two elements that can be found in both olivine and pyroxene. Okay, obviously this is not something you guys know off the top of your head. If I really thought about it, I might be able to get it, but like always, I always use my wonderful Earth Science Reference Table. So you have pyroxene and you have olivine down here. Okay, this is on page 6, but this actually isn't where you're going to get the answer. We need to go to page 16, all the way at the end, and we can find pyroxene. And where are you, olivine? Olivine's down here. Okay, so you can just look in these two chemical formulas, okay, and you may not know exactly what is in both of these, but it gives you the entire key down here. So let's look. Pyroxene, well, let's start with olivine because it's smaller. It has Fe and Fe. Okay, so Fe is iron, and it also has Si, and this has Si, which is obviously silicon. Okay, two very, very important rocks. So two elements, you can say silicon and iron. There's a lot of choices. Silicon, iron, there you go. Okay, you could put Si, Fe, or iron and silicon. Both would be completely correct. 56. What is the estimated age in years of Earth and our solar system? This is something that I hope that a lot of you know. The Earth is 4.6 billion years, but if you're unsure of it, of course, again, we can use our wonderful Earth Science Reference Table. One of the things that's hard about this is that you see over here it tells you the millions of years in age, right? It tells you the exact age of the Earth, and you say 4,600. Like it says, estimated time of origin of Earth and our solar system, 4.6 billion years ago. But it says 4,600 million years ago, okay, because it's a million years of age. So if you figure that out, okay, and if you need to add the zeros, you can do all that. But 4,600 million years is also considered 4.6 billion years. So if you could put 4,600 million years ago, that's fine. I typically would write it this way, or 4.6 times 10 to the ninth, I think, or you can use this. So any of those are acceptable. I think that's something that's probably maybe even common knowledge now, and hopefully you guys know that. Number 57. Explain why there is little evidence of meteorite impact craters on Earth. Well, when we look at the moon, we see, you can visibly see the craters on the moon. And you think of that and you're like, all right, well, if they hit the moon a lot and all the craters are there, well, how come we're not walking on craters all over the place on Earth? And the real reason is that the moon doesn't have an atmosphere like the Earth. Because they don't have an atmosphere, they also don't have rain, they don't have weathering, they don't have erosion, they don't have deposition. So without any of these different processes, the moon is going to show the craters. But because we have weathering and erosion, our meteorite impacts are completely covered up. There aren't many actually on Earth at all that we can see. There's few, especially in deserts, where it's not like a temperate climate or anything like that. And you can definitely see them. But 57, little evidence. It's going to be, okay, weathering and erosion. Most meteors are small, burn in the atmosphere. Okay, that's good. Okay, most of the surface is ocean too. You can think of that. And crustal plate movement. Okay, tectonic plates have destroyed the evidence.